Hello folks, we come to the exercise 1.2 part 5 video. We continue with our problems on 1 to 1 and on to. So here we have this function f from a cross b to b cross a, which is defined as f of ab to be equal to ba. The question says that you have to find if it is a bijective function. Show that it's a bijective function. So it is a bijective function. We have to show that it's a bijective function. So let's look for injectivity. Let f of a1 b1 be equal to f of a2 b2. So by definition it will become b1 comma a1 the ordered pair is equal to b2 comma a2 the ordered pair. So we know that when two ordered pairs are equal, the x coordinates will be equal and the y coordinates will be equal. So like that we will have b1 to be equal to b2 and a1 to be equal to a2. So a net effect we have got that a1 is equal to a2 and b1 is equal to b2. So when we write it, it will come to a1 b1 when we take, that will be equal to a2 b2. Why? Because a1 is equal to a2 and b1 equal to b2. So what has happened thus, starting from f of a1 b1 equal to f of a2 b2, we have reached a1 b1 to be equal to a2 b2. So f is injective. Then surjectivity. We have an element in b cross a. You should be able to find an element in a cross b. So let anything, an x comma y belong to b cross a. What is the meaning? X belongs to B and Y belongs to A. There exists an element Y comma X belonging to A cross B. A cross B such that f of y comma x will be equal to x comma y. Therefore f is surjective. And therefore from 1 and 2 f is bijective. Because it is injective and surjective, it is bijective. Injective is easy, can understand. Sometimes surjective may give, you may feel why it is like that. So it's like, there is an A cross B, there is a B cross A, there is A cross B, there is B cross A. Suppose I have an element here 4 comma 5. I will say, come on, you tell me who is its pre-image. Only if the pre-image is there, then only I will agree that it is onto and so on. So come on, you tell me now which is a pre-image. So we know that pre-image of this is going to be 5 comma 4, and that is belonging, and it should belong also. It is belonging. Why? Because we know that 5 is belonging to A and 4 is belonging to B. So by that logic, we know that 4 is belonging to B and 5 is belonging to A. So it will be there in that set. So that way. So this function is bijective. That's all about the question number 8. Now question number 9 says that there is a function from n to n which is defined in this way. This question is asking us to check whether it is bijective. Now what I would suggest is, let's plot it and find out how the function is, and then we can predict whether it is 1 to 1 or 2. Some initial point, natural numbers. So 1, 2, 3, 4, 5, 6, 7 and so on. Where will 1 go? 1 is odd. So 1 plus 1 by 2, 2 by 2, 1 can go to 1. Then 2 is even. So 2 by 2, it will also go to 1. Not 1 to 1, because 2 of them are going to one thing. 3 is odd, so it will go to 3 plus 1, 4 by 2, 2. 4 by 2, 2. Like that, this process will go on. So this is how the function is defined, right? So it's very clear from this arrow diagram that it is not 1 to 1, but it is on to. All elements have got pre-image, right? So that's what we understand from here. So let's write here. Let's look at the function question. What words they are using, we'll use accordingly. It's bijective, so injectivity. Here f of 1 is 1, f of 2 is also 1. Therefore 1 comma 2 has the same image 1. Therefore f is not injective. Right? Now surjective. Everything has got a pre-image. Okay, so for n belonging to n codomain, there exists pre-images which all can be there. See, when 1 is there, you've got double of 1 2 and 2 minus 1. When 2 is there, double of 2 4 and 4 minus 1. 3 is there, double of 3 minus 1. So whenever for n, it will have pre-images 2n and 2n minus 1 belonging to n domain, such that f of 2n minus 1 will be also n and f of 2n will be also n. Therefore f is surjective. F is not bijective. It's not bijective. Why? Because it's not injective, right? Now we come to the problem number 10, which is defined on the set A, that is real number minus 3, and B, real number minus 1. F of x is x minus 2 by x minus 3. Again, I think you have to check the bijectiveness. Check whether f is 1 to 1 and on 2. So first we'll check the 1 to 1. Let f of x1 equal to f of x2. So x1 minus 2. Yeah. Now solving. Let's take it on the other side. Open up. Plus 6. X1, x2 can cancel, 6 can cancel. We can have x1 coming on one side. So minus 3x1 plus 2x1 and minus 3x2 and 2x2. So it is minus x1 equal to minus x2. That makes it x1 equal to x2. So we'll write thus f of x1 equal to f of x2 makes it x1 equal to x2. So it is 1 to 1. On 2 also we will check like how we had checked the other time with y. We will check it like that. So on 2. For y belonging to which set B, there exists something belonging to A. Now what is that thing? I told you that in order to find that, we will do x minus 2 by x minus 3 equal to y. It's a rough work. So it is x minus 2 equal to y times x minus 3. That is yx minus 3y x minus 2. Let the y come here. Yx equal to minus 3y plus 2. X times 1 minus y equal to 2 minus 3y. Or rather, x is 2 minus 3y by 1 minus y. Now look at this function. This is what we are going to define. There exists 2 minus 3y by 1 minus y that belongs to A, such that, how we got it? We got it like this, okay? Such that you should find f of this. It should come to y. Such that f of 2 minus 3y by 1 minus y. What is it coming? Now f of anything by definition is this. So let's find this out. 2 minus 3y by 1 minus y minus 2 by 2 minus 3y by 1 minus y minus 3. you have to equalize if you have to work. So 1 minus y, 1 minus y, 1 minus y, 1 minus y. So 2 minus 3y minus 2 times 1 minus y by 1 minus y, and 2 minus 3y minus 3 by 1 minus y whole by 1 minus y. 1 minus 1, 1 minus y cancel. What is remaining here? 2 minus 3y minus 2 plus 2y by 2 minus 3y minus 3 plus 3y. So minus minus cancel, 2 can cancel, minus y, and here it is minus 1, which makes it y. So you have got a pre-image which is coming to y. Therefore f is on 2. From 1 and 2, f is bijective. F is bijective. So that's about the problem number 10. Now we have got 2 more. As I told you that over here we are going to take the MCQ questions very strictly, and we cannot take it lightly at all. So there are 2 MCQ questions that we are taking out in the next video. Thank you.